So we're going to start looking at sine and cosine functions. So essentially what's happening to the sine value as the angle changes. And we're going to get a function that's going to be looking like this graph that I've shown here. This curve is called a sinusoidal curve. So cos and sine both give essentially the same shape, and that shape is called a sinusoidal curve. So how do we get this curve? Okay, so we're going to look at the unit circle to do this. So again, just reminding you how we look at the unit circle. The x-coordinate of the unit circle is defined by the cosine ratio, or vice versa, and the y-coordinate is defined by the sine ratio, and vice versa. So here we have our positioning. This sine position is going to be the y-coordinate. This cos position is going to be the x-coordinate. So we can see the length x here and the length y here. And we have our four quadrants, quadrant 1, 2, 3, and 4, and they are separated by 90 degrees or pi over 2. So what's happening then? So as we increase the angle, as we rotate counterclockwise, as we rotate in this direction, we're going to generate sine values. So we're going to start with a sine function, and we're going to see how we come up with this curve. So we're going to look at the y values as we go around the circle. Okay, so looking at quadrant 1, as we go through quadrant 1, okay, as I trace through quadrant 1, I'm going to go from 0 all the way to pi over 2. And on the graph, what's happening on this unit circle, what's happening is we have a y-coordinate of 0 increasing to a y-coordinate of 1. And on the function, we have the same thing. As we go increase the angle to pi over 2, we're going to go from 0 y value to a y value of 1. So that part represents quadrant 1. As we switch to quadrant 2, we're going to continue here from 90 degrees or pi over 2 all the way down to pi. And as we're moving in this direction, we start with a y-coordinate of 1, but now we're going back down to 0. So that's going to be reflected in the function. So we start at 1 and we go back down to 0 when we hit pi. So that's quadrant 1 and quadrant 2. As we go through quadrant 3 now, quadrant 3, we're starting at 0, and as we rotate, the y-coordinate is becoming more and more negative all the way till we hit 270 degrees or 3 pi over 2. So that's what's happening in the function as well. We start at 0, and as we rotate, we're going down further all the way down to negative 1. And then going through quadrant 4, as we go through quadrant 4, the y-coordinate is increasing all the way back to 0. So on my graph, the y-coordinate is increasing all the way back to 0. And once we hit 0, it starts repeating itself. So this is what we call a cyclical function or a repeating function. Okay? And the repeating period is going to be 2 pi or 1 full circle. So when we look at the sine function, so this graph is a sine function, so it's to do with the y positioning. As we go around the circle, it goes up through quadrant 1, down through quadrant 2, back down to 0, and through quadrant 3, we go through down to negative 1, and back up to 0 as we go through quadrant 4. Okay, so this is the pattern that this is going to follow, and this is what generates the function, or this is what we call sinusoidal curve. So this function now is y equals sine x.